So in this one, we have to justify by using the equation. Look, when we write the value for a Kp, the Kp will be a product divided by reactant. So the pressure of hydrogen iodide square divided by the pressure of the hydrogen times the pressure of iodine. Okay. Look, we are not changing the temperature, so the Kp won't change. But what happened to the mole fraction? The mole fraction will also, it will remain same. Why it will remain same? Because we have like the total two particles of in the reactant side and two particles in the product. So if I increase the pressure, like let's say it was 2 and 2, but if I double the pressure, this will become 4 and this will also become 4. If I triple the pressure, this will become 6, this will also. So the value of the mole fraction does not change because we have equal number of the moles of the reactant and the product for the gaseous moles of the reactant product. So the mole fraction remains same. That's why the pressure won't affect the equilibrium. So means if the value for the Kp was 1, or let's say the value of the Kp was 2, and initially the mole fraction was also 2. Now if we double the pressure, so if this might be 6, this might be 3, so the mole fraction remain 2. If we triple, this might be 18, this might be 9, so it will remain 2. So the mole fraction remains unchanged. So in the answer, what you're supposed to write the structure. Like you will say that there is no effect of the pressure because we have equal number of moles of reactant in the product side. So the mole fraction does not change. And if the mole fraction does not change, it won't affect the equilibrium. So you don't have to write the equation there. You are supposed to write the statement that the mole fraction, like equal number of moles of reactant in product. So the mole fraction does not change with the pressure. So equilibrium is not affected by pressure. Explain how increasing a temperature affects the total entropy of the reaction. Assume system does not change. Okay, when the temperature increase. So what we have, see, remember the entropy topic. The total entropy is the entropy of the system plus the entropy of the surrounding. And it will be entropy of system because entropy of surrounding is minus delta H by T. And if you see the question, the forward reaction is exothermic in nature. Like a delta H value is negative. So if the delta H value is negative, like this will be negative when I simplify. So this will be entropy of the system plus delta H over T. When I take T as an LCM, you don't have to show this working. I'm just giving an equation. Then I will use that equation to explain the reason. So there's a temperature. It will be entropy of the system times T plus delta H. This is the equation for us. Now what they're saying, assume that the total entropy does not when the temperature increase. So total entropy of the system is not changing. How did we know enthalpy change is negative? It's given in the question. They mention in the question here that it is minus 10. So it's an exothermic reaction. So they already specify in the question that it is minus 10. So that's what we conclude. So what will happen to the total entropy? This is not changing. This is increasing, but the temperature is also increasing. Or you can also justify from, so if the temperature is increasing, if there's an increase in temperature, what will happen to total entropy? The total entropy will decrease. Or you can also justify because if temperature is coming in two equations, it will be difficult. So if we write that the total entropy is the entropy of the system plus the entropy of the surrounding. And here, this is minus the formula of entropy of surrounding is minus delta H over T. But reaction is exothermic, so negative will be positive. So this will be entropy of the system plus delta H over T. That is equals to total entropy. Now, they already mentioned the entropy of a system is not changing, does not change. So this is a constant factor. Delta H is fixed because the reaction is there. Now, what happened if I'm increasing a temperature? So when I increase the temperature, what happened to this value? Because if the denominator is greater, increasing, so this value will decrease. So if this value, this remain constant and this value is decreasing, so what happened to total entropy? The total entropy will decrease. So how to write? You're not supposed to use write the equation, but you're supposed to use the term. So you will say that total entropy is a system plus the surrounding. The system does not change, and the surrounding is the reaction is exothermic. So the surrounding will be delta H over T. So as the temperature rise, the total entropy of the surrounding will decrease. So the sum of the system and the surrounding will also decrease. Is it clear? How the total entropy changes for this reaction? Anyone having a doubt or a question? The next, use your answer to C1, explain the effect of increasing temperature on the Kp and the equilibrium yield of hydrogen iodide. So what will happen? This reaction is exothermic. Remember, for exothermic reaction, if we increase the temperature, what happened to the value of the Kp? Kc or a Kp, the value will decrease. Because the total entropy is decreasing. And there's a relation between a total entropy and the Kc or a Kp. That is the ln K, like Kc or a Kp, is equals to, or you can also learn from R, the total entropy is equals to R ln K. That's a formula. Like which shows the relation between this K is, it can be Kc or a Kp. That's why it's written only K. So what happened when we increase the temperature, the value of the Kc or a Kp, it's an exothermic reaction, so it will decrease. So the value of the Kc and Kp will decrease. So what happened to total entropy? As it is directly proportional, so the total entropy will also decrease. Is it clear? Because so 1 mark will mention the reaction, the forward reaction is exothermic. So increase in temperature, decrease the value for Kp. And the second mark, as the value of a Kp decreases, it's directly proportional. The total entropy is directly proportional to ln K. So if the value of the K decreases, the value of ln K will also decrease. So the total entropy will also decrease here. Is it clear? Question 8. Ester is there, can be formed by reaction of propanoic acid and methanol. The first name of ester is from alcohol and the second name is from carboxylic acid. So what is the name of this ester? Methyl propanoate. The same product can be made by propanyl chloride instead of propanoic acid. So this is related to organic chemistry, so we'll skip right now. Complete the table in each of each substance present at equilibrium and use the value to calculate the value for Kc. So initially we have 0.52, 0.52, 0 and 1.2. So water was originally present, that's why we wrote 1.2. At equilibrium, this many, so how many moles are produced? So 0.21 moles are produced. So we know the ratio between them according to equation, all have a ratio 1:1. Like when you see the original equation, all have the ratio 1:1. So if, how many moles of propanoic acid will be reacting? Because if the ratio is 1:1, 1 mole is giving 1 mole. So there is 0.21 moles. If there is 0.21 moles of the product are formed, how many moles will be reacted? X, so we'll get a 0.21. 0.21 will react, but it's not like how many reacted. We need how many are left at equilibrium. So originally it was 0.52, and out of 0.52, 0.21 moles are reacted. So how many are left at equilibrium? So we subtract. So this will be 0.31 moles will be left at equilibrium. Same thing, the ratio between them is also 1:1. So same number of moles will be reacting. And how many, it's not like how many react, it's how many left. And same number of moles of water will be produced. So originally we have like some water is there 1.2 and now produce a 0.21. So what is the total number of moles of water? So it will be 0.33. These are the total number of moles of the water. Then we need the value for Kc. Kc is a product divided by reactant, but these are the moles. We need the concentration. So concentration is moles divided by volume. In the question, the volume of the container or volume of the solution is not given. So we call that as a volume V. So when I write the formula that Kc will be a product Kc will be a product divided by reactant. So how many moles are there for the product? It is 0.21. But divided by volume, we call volume as V. Because we don't know in the question, the volume of the solution is not given. So we call V. The moles of water are 0.33 and the volume is V. The moles, and because they are all mixed together, so they will have the same volume, which we are calling that V. 0.31 over V, and this will be 0.16 over V. All V's are there, like they will cancel out, like this V cancel out with this one, and this V cancel out with this one. So actually it's like the moles of the reactant divided by moles of the product. So when moles of the reactant divided by moles of the product, what we will get? We'll get the value for Kc, which is 5.97. And 5.97, this does not have any unit. Why this Kc has not having unit? Because the like you can see the power of the numerator, the total power of the numerator, which is 2, and the total power denominator is also 2. So they cancel out each other. That's why in this case, the Kc will not have any unit. Is it clear, this question? Any doubt in this?